Hello everyone, welcome back. So in this session we are going to discuss an scenario based example for a context free grammar under CNF conversion. Okay, so I have taken an example which consists of a context free grammar representation of a grammatical English grammatical sentence. A sentence will have a noun portion followed by a verb portion, and the noun portion will have a determination and followed by a noun or something. Okay, and again verb portion consists of a verb followed by a noun portion, and it goes on like a normal grammar structure. And your noun consists of your determinator might be the or a, and noun portion consists of cat, dog, ball, park, or anything. And verb portion is like any verb: playing, chasing, saw, slept, and all. So these are all some examples. Okay, so now with this grammar we are going to list all the terminals, non-terminal. This is the question portion. Whatever I have written in black is the questions. So we have to list all the terminal, non-terminal, and we have to derive a parse tree, leftmost derivation, rightmost derivation for the given statement. And we have to simplify the grammar, convert the grammar into a Chomsky normal form structure. So we'll start one by one. So first step is to list all terminals and non-terminals. Your non-terminals nothing but like your variables. Okay, and what is a variable? A variable is something that is written in this side. Okay, so all these things are your variable, and that has a definition for itself. So what will be your variables or a non-terminal? Your S, NP, VP, PP, whatever is written in this side. Okay, X, DET, EN, V, and P or your non-terminals. Okay, and what will be a terminal symbol then? A terminal symbol is something other than your, in the definition, other than your variables. Okay, except your NP, VP and all. Whatever you have, that will be your terminal symbol. Okay, so we'll see one by one. In the first place, S tends to NP, VP. S, NP, VP, everything is a variable. DET is a variable, N is also a variable, and DET, N, PP, everything is a variable. Okay, so where you have your terminal symbols or these things: the, cat, dog, park, ball, chased, saw, slept, in, on, with, under. So all these things are your terminal symbol. Okay, when you write all, that will be your terminal symbol. So what are your terminal symbol? The, cat, dog, park, ball, chased, saw, slept, in, on, with, under. So all these things are your terminal symbol. Okay, now we know what is the definition between a terminal symbol. Non-terminal is nothing but your variable. Okay, now you know what is a variable, what is the terminal symbol, what is the non-terminal symbols and all, right? So first question is done. And what is the next question? We have to derive a parse tree. For the given grammar, using this, for this statement, we have to derive it. Okay. Okay, so let us take this. For deriving this, your starting symbol, I'll draw parse tree directly. That is easy way of representation. Then we can go ahead with your leftmost derivation, rightmost derivation. Okay, so we'll start with S. S is the starting node. So we have to start with S all the time. Okay, now started with S. S has only one production. So you have to replace S with this only one production, NP followed by VP. Okay, so each time we have to compare with the statement that you have, and you have to apply its corresponding production. So now NP can be replaced with either DETN or DETNPP. Okay, so the suggestion is yours. You have to take any one and check whether it is matching with the string or not. Okay, so what we can do is, when I replace DET, so first two half is same. Okay, so you have DET and N. DET can be replaced with the, it matches, and N is replaced with cat, cat also matches. Okay, and it is then we have to verify whether we want to follow this PP here. What is PP? PP consists of P and NP. Okay, but what exactly needed is chased. After the cat, I want a verb portion over here. So what I can do is, instead of going ahead with PP, I'll take the first production. Okay, this NP can be replaced with det and n. So det takes the, n noun takes cat. Okay, since I want the cat and it is then followed by a verb portion. So I want chased. So what I have to do, I have to start replacing VP here. And what all the productions I have to replace with VP? VP has either this or a single verb. Okay, so I want a statement after a verb. I have some other statement, so I cannot use this. So I have to verify whether I'm going to take VNP or VPP. Okay, so now your variable verb portion consists of chased, and it is then followed by chased, and you can replace the next element that is needed is a noun portion. Okay, we don't want a PP over here. So what we have to do, we have to take the first production. Okay, you have to check all possible conditions here. So when I replace V and NP, so this verb can be replaced with chased. Okay, and NP can be again replaced with, after this chased, what we have the dog. Okay, so the is again it is the replacement for NP. We have to look at this production. For NP, either it is DETN or DETNPP. So what all we have here, your DET is your the, and N consists of a noun portion. Noun portion might be either cat or dog or park or ball. I wanted dog, so I can replace it. But this is then followed by in the park. Okay, so to expand in the park, I want PP. Okay, since PP tends to P and NP, P consists of in, and we have to look all possible conditions here. Okay, so what we have to do, we have to replace this NP with DET NPP. Okay, so this DET take the, N takes dog. Okay, so the cat chased the dog, and you have PP. And what you have to replace with PP? PP has only one production, that is P followed by NP. And what is there in case of your P? P consists of either in, on, with or under, and what is needed? It is in. In is what needed. Okay, the cat chased the dog in, and what is the last sentence that is needed? The park. Okay, so the is in DET and park is in, where you have park, in N. Okay, so this NP can be replaced with this production DETN. Got it? So DET tends to the and N tends to park. Now check whether we have derived the complete statement. The cat chased the dog in the park. It's completely done. This is how we have to derive a parse tree. Okay, so parse tree derivation, when you are doing it on your own, you have to find all possible conditions, and we have to find a way whether we can replace some of the variable with its corresponding production that matches with your input. Okay, so this parse tree is easy. So once you are able to derive the parse tree, next step is derivation. Derivation is exactly converting this parse tree into your leftmost and rightmost derivation. Now we have to show how to write a leftmost derivation for it, rightmost derivation for it. So I'll start writing your leftmost derivation. So first S can be replaced with, what production we replace S with? NP, VP. Okay, and what is the leftmost derivation here? We complete your leftmost portion first, like we derives your leftmost variable first, and then we can go ahead with the rightmost. Okay, so first I take NP. NP can be replaced with DETN and followed by your VP, and S tends to, instead of DET we substitute, like we have three variables here. I take the leftmost variable first. In all the places use this LM over here, and DET is replaced with the NP VP, and instead of N we replace it with cat, and you have VP, and you have S tends to the cat, and what we have replaced VP with, it's V and NP. And again what we have to do, the cat, and instead of V we have to use chased NP, the cat chased. Instead of NP, what we have replaced NP with? DET NPP. Now you have three variables here. In the three variables, we are going to replace the leftmost variable first. Okay, the leftmost variable DET can be replaced with the, and you have NPPP here. And again, the cat chased the. Now N can be replaced with dog, okay, followed by PP. Now I have only one variable, and this one variable PP is replaced with P and NP. So you have to write the entire statement here. So all these things, after dog you have PP replaced with P and NP, okay, and again the complete statement till dog, and this P is replaced with in followed by NP. So each time we take only one variable and replace it. So this NP can be replaced with, what you have replaced this NP with? Det and N, okay, and again you have the entire statement followed by the N. So the final statement is the cat chased the dog in the park. Okay, this is your final derivation. You have to write all these quotations. Okay, when you fill, this is your leftmost derivation. So when you have a lot of variable, I always keep on replacing the leftmost element first. See, so here first I have NP, VP, I take the leftmost variable NP, and when I have three variables, I replace det with the. Okay, so this is how we write a leftmost derivation. And what will you do for your rightmost derivation? You have to start going back of it. Okay, so I'll show you some portion of it alone. I don't take the entire statement here. Okay, so now when I want to replace or when I want to derive a rightmost derivation for it, first I start with S. S is replaced with NP, VP as it is. And now this is your rightmost derivation, right? I have to focus on the rightmost variable first. So this VP can be replaced with VNP. Okay, and then this NP will remain as it is, V will remain as it is. Instead of NP, we replace NP with DET-NPP. Okay, and you have NP, V, DET-N. Now instead of PP, what you have made a substitution, it is P followed by NP. Okay, and each time when you have a lot of variable, we just focus on the last variable alone. DET-N, NP. And this NP is replaced with, now the last variable is NP. So NP is replaced with, what you have made your NP replaced with? It is DET-N. It's DET and N. Now what is the last leftmost variable? All this. You have DET. Instead of N, what you have replaced? Park. Okay, so your replacement goes from this right to left. It is your rightmost derivation. Now and again you have to replace this DET with the, P with N, N with dog, and DET with the, V with chased, and it goes on. So when you are replacing things with this condition, we call it as a rightmost derivation. Starting from the right variable, we keep replacing things. Okay, so this is your rightmost variable. So now we know how to draw a parse tree. Leftmost derivation, rightmost derivation. And the next one is simplification of the grammar. So simplification have three steps. So first step is removal or elimination of useless symbol. And what is a useless symbol here? We have two types of useless symbol. Remember, you have your non-generating symbol or not reachable symbol. Okay, so non-generating symbol is one which doesn't generate to any of your terminal symbol. See, after parse tree, it is very easy here. See, when I take S, S is the place where it all derives, right? So S derives to some set of the given input is derived using your S. So we can call S is derivable. And again, NP, when NP is replaced with something, it derives. Okay, your S is deriving to some set of terminal symbol. When you have NP, NP can be substituted with DET and N. DET can be substituted with the, N can substitute with your cat. So NP is deriving. I can tick those things. S is deriving, NP is deriving. Okay, your DET can be replaced with the, N can be replaced with DET is replaced. So all your production rules where you have a terminal symbol. See, DET can be replaced with the, N can be replaced with cat or dog or park or ball. So these are all your terminal symbols. So when it derives to some leaf nodes, then we call that as a deriving symbols. Okay. And again, VP can be substituted with something, and that also your parse tree stops. Okay. So you can, your VP can be substituted with V and NP. And again, V can be substituted with chase, and NP can be substituted with something. Anything that you substitute and your process stops. See here. See, you derives to some set of elements in the parse tree, right? You don't have any variables at the leaf node. It stops derives, right? So what we call that as a generating symbol. Okay, again, what happened to PP? See, here we have PP substituted with P and NP. Again, this derives to in the park, right? So when PP comes into a picture of a parse tree, it is able to derive in the park as a set of terminal symbols. So this is also allowed, this is also generating. Now think about a new variable here, you have X. So X can be replaced with X and VP, and again this X can be replaced with X and VP, and you don't have any other production for X, right? So X always keeps X and VP, which is not going to stop when you're deriving a parse tree. Okay, these kind of symbols we call it as a non-generating symbol, and we remove it from the grammar directly. Okay, so in this example your X is non-generating. Okay, so next you have your not reachable symbol. Not reachable, I use another color for not reachable symbol. So anything that is not called from the starting symbol, we call it as a not reachable symbol. So you have S is your reachable symbol. So S is, I'll take blue. So S is your, okay. So S is reachable, right? So S is the starting symbol, and S calls NP and VP, and NP calls DET and N. Okay, in the production of NP, it calls DET, N and PP. So all these things are reachable when I am deriving from the starting symbol. And again VP calls V, so V is also reachable, and PP calls P, so P is also reachable. Okay, so all those variable in the place are reachable, so you don't need to go ahead. So there is no not reachable, but only one non-generating symbol. So X is non-generating, so you're going to replace this X as a whole. Okay, so this is your first step in simplification, and second step is elimination of epsilon production. In the given grammar we don't have any epsilon production, so we don't need to remove it. And what is the last step? Your third step in simplification is unit production. So where you have a unit production, here unit production is a variable tends to another variable, one variable tends to other variable. So S tends to NP, VP, you have two variable. So here you have one production, so you have VP tends to VNP or VPP or V, right? So this is a unit production. We cannot call this as a unit production. A variable tends to variable is a unit production. Here a variable calls a terminal symbol, the cat, dog, or your terminal symbols. Okay, we don't call this as a unit production. So only one unit production we have here. So what we can do is this V can be replaced with NP, VP, PP. Instead of V, we have to substitute the production for V. And what is there in the production for V? You have chased, saw, slept. So these are all the productions. I can directly substitute it. Okay, when you make a substitution, your production will be this eliminates your unit production from the grammar. So this is your simplification steps. We have 3 steps of simplification. One is removal of useless grammar or a useless production. So there are 2 types of useless symbol. One is non-generating, another one is not reachable. And next one is epsilon production elimination, and next one is unit production elimination. Okay, now the grammar is free from all your unit production, epsilon production, or your empty productions. We can remove everything. What is the last step? Last step is convert the grammar into, last question is convert the grammar into CNF structure. So how can you convert a grammar into CNF structure, dear? Now this is the final grammar we got after eliminating all the useless symbols, empty production and epsilon production, unit productions and all. So finally you have to convert this grammar into a CNF, Chomsky Normal Form structure. What is the general form for Chomsky Normal Form? A variable tends to 2 variable, or a variable tends to a single terminal symbol. This is your general format. Okay, so what we have to do is check the body of the production, and if it is in the structure we are going to leave it. See, S tends to NP, VP. So NP is a variable, VP is a variable. It is allowed. DET, N, again variable, 2 variables it is allowed, and here is the case like you have 3 variables which is not allowed. So you have to replace NP into DET, NPP. This is not in your CNF structure. And here you have VP, NP which is allowed, VP, PP it is allowed, and chased, saw and slept or single terminal symbol. A variable tends to single terminal symbol is allowed. Again VP, P and NP it is also allowed, and here is all single terminal symbol, which is all allowed. So all these things are allowed. So what is left which is not in the CNF structure is only one production, that is NP tends to DET NPP. It is not in your CNF structure. What you have to do is you have to create a new variable called NP dash, and that will take N and PP. Okay, so now you can replace the production as NP into NP as DET NP dash. Okay, so this one single production is divided into two. So these two variables, I'm going to add it as a new variable. I'm going to create a new variable as NP dash that consists of N and PP. And instead of N and PP, I'm going to replace it with as NP dash. Okay, so again now check the grammar. Your production consists of two variables, which is allowed. Okay, so this is how you convert a grammar into a Chomsky normal form structure. Okay, thank you.